Okay, now I want to take a look at limits, not graphically, but using numbers, and how to start to understand the algebra behind limits. So we'll title this video Estimating Limits using numbers. Estimating limits using numbers. Okay, and so the instructions for these types of problems could be something like this. Estimate the limit using, let's say, a table of values. Estimate the limit using a table of values. And those will be the instructions we use for all of the examples in this video. Now, the first example, let's say we want to determine, sorry, I already have the instructions, so estimate this particular limit. So let's say we have the limit as x approaches 4. So that's as x approaches 4 from both sides. The limit as x approaches 4 of this particular function, x squared minus 4x over x squared minus 16. Okay, now since we have a two-sided limit here, we need to look at both one-sided limits, the left-sided limit, the right-sided limit, and see if they're the same. Okay, so we'll break this into two parts where we find, or we try to find, the limit as x approaches 4 from the left. And let's call this guy, let's give it a name, let's call it f of x, so you don't have to keep rewriting the fraction. So the limit as x approaches 4 from the left of f of x, we'll look at that. And we'll also look at the limit as x approaches 4 from the right of that function f of x. And we'll see what we get. And if they're the same value, then we can conclude what the two-sided limit is, okay? Now, how do we do this? We don't have a graph of this function. We don't want to try to graph it. In fact, often what we'll do in calculus is we'll use what we know about limits to help us get the graphs of functions like this, okay? Because if you notice, this particular function is not defined whenever x equals 4. If you plug in 4 for x, you get 16 minus 16, which is 0 on the bottom, and you can't divide by 0. So to me, that's what limits are really useful for many times, is if a function does not have an output at a particular input, why not look at values close, infinitely close to that, to understand what happens near that x value? And that's what we're going to figure out here, okay? So we're going to look at near 4 from the left and near 4 from the right and see if we can find something out. So this says use a table of values. So let's set up our table. So we'll have an x column and an f of x column, same as y. And for this particular limit, what we're going to do is approach 4 from the left. We need to get really close to 4 from the left. Technically, we have to get infinitely close. So we're going to work to see if we can estimate this limit, hopefully using technology to help us estimate this limit by getting kind of close, not infinitely close. So we're approaching 4 from the left, so that's on a number line, here's 4, we need to be on this side. So we might start at an x value of 3.5, and then maybe go to 3.9, that's pretty close to 4. But even closer is 3.99, and so on and so forth. We could keep going. Now, eventually, if you get really close, your calculator or whatever device you're using could run out of memory or something. So this is not a guaranteed way to find limits, but lots of times it's a pretty good way. So I'm going to use my scientific calculator here, which I'll show you in a minute, to figure out the y values, the function values that go with these inputs, and we'll see if we can determine what this left-sided limit is, okay? So I have a TI 36X Pro. It's one of my favorites. Pretty cheap calculator, easy to use. I'll turn it on here and I'll kind of walk you through the steps. So the first thing I want to do is I want to type this formula into the calculator, and then I want to generate a table for that formula, okay? So if I want to type a formula in, I'm going to go, let me see if this will focus for me. There we go. I'm going to hit the table button, and I need to edit a function. So I'm going to hit the down arrow, enter on edit the function, and I'll clear this function out. And I need to type a fraction. So I'll hit my fraction template here, right? And now I need to type my numerator. Well, I have an X button right here. So I'll hit X, and then I need to square it. So I'll hit the square button, minus 4x, so there's my numerator, x squared minus 4x. I'll have my down arrow, and now I'll type x squared minus 16, oops, let me hit delete, I hit a wrong button, and enter to save that formula. Now I've got to set up my table. Now you could do an auto table, but I like to just manually type in the x value. So I hit the down arrow twice to get to x equals, and I'll hit enter, and then enter again to calculate. Now there are already some x values and f of x values here, but I want to use the ones we had in our table. So I'm going to type 3.5 for my first x value and hit enter, and you can see the y value is 7/15. Then I'll type 3.9 for my x value, enter, and the y value is 39/79. Then I'll type 3.99 for my x value, and I get 399 over 799. Let's keep going. Let's go to 3.999. By the way, I recommend if you have paper nearby, you're writing these values down in your table. I'm not doing that because I'm so far from the whiteboard right now. Okay, now I finally got a decimal, which is easier for me to see. I get 0.499937492. Let's go one more step and do 3.9999. And look at that, it appears to be approaching 0.5, which is a half. Okay, so we're going to estimate this limit to be the y value of 0.5. So I'll come back over here. Let me make sure we're focused. And I can say that the limit, you should have filled in your table here. The limit as x approaches 4 from the left equals 0.5. We're assuming it's 0.5 based on the pattern we saw. Let's do the same thing for the right-sided limit. And now I need to pick x values that are bigger than 4 and getting close to 4 from the right. So maybe I'll use 4.5, and then I'll get closer to 4, so 4.1, 4.01, etc. Now we'll fill in the y values using the calculator again. Now the good news is my function's already stored, so all I have to do is go up and type my new x values. So 4.5, enter. 4.1, enter, 4.01, enter, oh, syntax error, hit a wrong key, let me clear that out, 4.01, I hit, sorry, I'm having trouble, it's tough to do this and record, 4.01, there we go, 4.001, and look at that, it looks like we're getting close to 0.5 on that side as well. Let's go one more, 4.0001. Yeah, it looks like we're getting close to 0.5 again. So now, this guy is also 0.5, so the left-sided limit and the right-sided limit are getting close to 0.5, which means that, in turn, the two-sided limit, since these are equal, the two-sided limit also equals 0.5, or 1/2. And that's how you estimate the values of a limit using numbers, okay? Let's try another example. same instructions, so I'll leave those there. Let's say we want to find the limit as x approaches, let's see, how about the limit as x approaches 0 from the right of the tangent of x plus pi over 2, okay? So now we have a trigonometric function. Again, when you have a trigonometric function and you're approaching a value, you want to make sure your calculator, if you're going to use a calculator, is in radians mode. Because notice pi over 2 is not a degree measurement, it's a radian measurement. And traditionally with calculus, you're going to use radians anyway because you don't want your angle to have a unit such as degrees. You want it to be unitless, which is why radians are so useful. So make sure your calculator is in radians mode. But we need to set up a table, x, and then let's call this again, maybe we'll call this g of x now. And we need to approach 0 from the right, so 0 is on the number line. We'll start over here and we'll work our way closer to it. So maybe we'll start with 0.5, then we'll go to 0.1, and then we'll go to 0.01, and then we'll go to 0.001, and we'll see how much we need there to get a good handle on what's happening with this limit, okay? All right, so I've already gone back to the function part. Remember, that's under the table area, so I'll clear the function that's there. And you'll notice here I'm in radians mode, so I'm good there. And I'll type tangent, parentheses, x plus the fraction, so I'll hit my fraction template. And then I need my pi button. Let me see if I can find that here. Pi, down arrow, 2. Right arrow, close the parentheses. So I've got my function typed in now. Now I hit enter to save that. And then I'm going to go down to x equals. I want to type those in manually and not do auto. Enter to calculate. And so now I'll type in the x values we had. So I've got 0.5, enter. I get a y value of negative 1.83 and so on. Then I'll type 0.1, then I'll type 0.01. You can see my first y value is negative 1.8, then I've got negative 9.9, then I've got negative 99.9. It looks like, maybe you can decide what's happening here. If I put in 0.001, I get negative 999.9. It looks like the y values are growing, right? They're getting big really fast. And they're getting big in the negative direction. So what we might say is that f of x is approaching negative infinity as x is approaching 0 from the right, okay? Or not f of x, but g of x. So in this case, what we can say is, as x gets close to 0 from the right, this guy, this g of x function, was going to negative infinity. So this limit equals negative infinity. Now, just a reminder, a limit should output a finite number, so this limit technically doesn't exist, but we often write negative infinity to indicate the behavior. So you can imagine if you were to graph this function and you were getting close to 0 from the right, if you're getting close to 0 from the right, the y values would be going down. That seems to indicate a vertical asymptote on your graph at 0. And as you approach that asymptote from the right, you're going to go to negative infinity. Okay, so there are a couple examples of evaluating limits using numbers. Play around with your calculator, see if you can find a table mode or something that might be useful or make that fast for you. You can also, you could type the formula here, and then you could store different values in for x, like you might store 0.5 in for x, and then recalculate the value of the function or the expression for that x value. You could then store 0.1 in for x and recalculate, and you could use the store and recall, the store feature to calculate different outputs of this function. Or you could just do it very manually, where you go in and you just type your x values in right here and keep reusing the formula that way. Just find whatever you're comfortable with and whatever's fastest for you. But that's it for estimating limits using numbers.